To be qualified to design and stamp electrical plans for new buildings, you typically must meet certain requirements. In most states, only licensed professional engineers, abbreviated PEs, are authorized to design and stamp electrical plans for buildings. To become a PE, you typically need a bachelor's degree in engineering, such as electrical engineering, from an ABET-accredited program. Most states require PE candidates to have a minimum of 4 years of relevant engineering experience under the supervision of a licensed PE. To obtain a PE license, you must pass the Fundamentals of Engineering exam and the Principles and Practice of Engineering exam in your discipline. In some states, additional training or continuing education may be required to stay current with building codes and industry standards. To design and stamp electrical plans for new buildings, you most likely need to become a licensed PE. The steps to begin the PE process are as follows. Firstly, complete your bachelor's degree. Obtain a bachelor's degree in electrical engineering from an ABET-accredited program. Secondly, pass the FE exam. Apply to take the Fundamentals of Engineering exam in electrical engineering. Thirdly, gain experience. Work under the supervision of a licensed PE to gain relevant experience. Fourthly, pass the PE exam. Apply to take the Principles and Practice of Engineering exam in your state. Fifthly, obtain your PE license. Submit your application for a PE license along with proof of experience and exam results. The Fundamentals of Engineering exam, also known as the FE exam or the Engineering Training exam, is the first step towards obtaining a professional engineer license in the United States. It is a standardized exam administered by the National Council of Examiners for Engineering and Surveying, abbreviated NCES. The FE exam is designed to assess a candidate's knowledge and comprehension of fundamental engineering principles. It is typically taken by students who are nearing the completion of their bachelor's degree in engineering or by recent graduates. The exam covers a broad range of engineering topics, including mathematics, basic sciences, engineering, economics, statistics, ethics, and various engineering disciplines such as chemical, civil, electrical, and mechanical engineering. The FE exam is computer-based and consists of approximately 110 multiple-choice questions. Candidates are given 6 hours to complete the exam, which includes a tutorial, a break, and the actual exam time. The exam is graded on a pass or fail basis, and the results are reported to the candidate and the state licensing board. Passing the FE exam is a significant milestone in the process of becoming a licensed professional engineer. It demonstrates that the candidate has a solid foundation in engineering principles and is prepared to continue their professional development. After passing the FE exam, the next step is to gain relevant engineering experience under the supervision of a licensed PE. Once the required experience is obtained, the candidate can then apply to take the Principles and Practice of Engineering exam in the specific engineering discipline. The Principles and Practice of Engineering exam, also known as the PE exam, is the second and final exam required to obtain a professional engineer license in the United States. It is a standardized exam administered by the National Council of Examiners for Engineering and Surveying, abbreviated NCES. The PE exam is designed to assess a candidate's competency in a specific engineering discipline, such as civil, electrical, mechanical, or chemical engineering. It is typically taken by engineers who have gained several years of relevant work experience after passing the Fundamentals of Engineering exam. The PE exam is more focused and in-depth than the FE exam, covering advanced engineering concepts, problem-solving techniques, and practical applications related to the candidate's chosen discipline. The exam format varies depending on the discipline but typically consists of multiple-choice questions, essay questions, or a combination of both. Candidates are given a specified amount of time, usually 8 hours, to complete the exam. The PE exam is graded on a pass or fail basis, and the results are reported to the candidate and the state licensing board. Passing the PE exam is the final step in the process of becoming a licensed professional engineer. It demonstrates that the candidate has the knowledge, skills, and experience necessary to practice engineering in their chosen discipline. After passing the PE exam, the candidate can then apply to the state licensing board to obtain their PE license, which allows them to legally practice engineering and stamp engineering drawings. The Accreditation Board for Engineering and Technology, abbreviated ABET, is a non-profit organization that accredits college and university programs in the disciplines of applied and natural science, computing, engineering and engineering technology at the associate, bachelor's and master's degree levels. ABET accreditation provides assurance that a college or university program meets the quality standards established by the profession for which the program prepares its students. ABET accreditation is a voluntary process that involves a rigorous review of a program's curriculum, faculty, facilities, and student outcomes. The accreditation process is conducted by teams of volunteer experts from industry, government, and academia. ABET accreditation is widely recognized as a symbol of quality in higher education, and it is often required for graduates to be eligible for professional licensure or certification. ABET accreditation is important for a number of reasons. Firstly, it ensures that students are receiving a high-quality education that prepares them for successful careers in their chosen field. Secondly, it helps employers identify graduates who have the knowledge and skills necessary to meet the demands of the workplace. Thirdly, it promotes innovation and continuous improvement in engineering and technology education. Fourthly, it provides a framework for programs to assess their effectiveness and make data-driven decisions about program improvement. ABET accreditation is a valuable asset for students, employers, and the engineering and technology professions as a whole. It helps to ensure that graduates are well prepared for the challenges of the 21st century and that the United States remains a leader in innovation and technology. To maintain a PE license, most states require professional engineers to complete continuing education requirements on a periodic basis. These requirements are designed to ensure that engineers stay up to date with the latest advances in technology, changes in regulations, and best practices in their field. The specific requirements for continuing education vary by state, but they typically involve completing a certain number of professional development hours, abbreviated PDH, within a specified period, such as 1 or 2 years. One professional development hour typically represents 1 hour of instruction or training. Activities that may qualify for continuing education credits include attending conferences, seminars, workshops, and training courses, completing online courses, participating in professional society meetings, teaching engineering courses, publishing technical papers, and obtaining patents. Some states may also require engineers to complete courses in specific areas such as ethics, safety, or risk management. Engineers are typically responsible for tracking their own continuing education activities and maintaining records of their PDH. They may be required to submit documentation to the state licensing board to verify their compliance with the continuing education requirements. Failure to meet the continuing education requirements can result in disciplinary action, such as suspension or revocation of the PE license. Continuing education is an important aspect of maintaining a PE license and ensuring that engineers are competent to practice in their field. By staying up to date with the latest developments in engineering, engineers can provide better service to their clients and protect the public health, safety, and welfare. Building codes are a set of regulations that govern the design, construction, alteration, and maintenance of buildings. They are put in place to ensure the safety and welfare of building occupants and the general public. Building codes cover a wide range of topics, including structural integrity, fire safety, electrical systems, plumbing systems, mechanical systems, energy efficiency, and accessibility. Building codes are typically developed and adopted by state and local governments. They are based on model codes developed by organizations such as the International Code Council, abbreviated ICC, and the National Fire Protection Association, abbreviated NFPA. The ICC publishes the International Building Code, abbreviated IBC, the International Residential Code, abbreviated IRC, and other model codes that are widely adopted in the United States and other countries. The NFPA publishes the National Electrical Code, abbreviated NEC, which is the standard for electrical safety in the United States. Building codes are constantly evolving to reflect new technologies, materials, and construction practices. They are typically updated every 3 to 5 years to incorporate the latest advances and address emerging issues. Compliance with building codes is essential for ensuring the safety and durability of buildings. Building officials are responsible for enforcing building codes and inspecting buildings to ensure that they meet the required standards. Failure to comply with building codes can result in fines, penalties, and legal action. Building codes play a critical role in protecting the public health, safety, and welfare. By setting minimum standards for building design and construction, they help to ensure that buildings are safe, durable, and energy efficient. Electrical design is the process of planning and creating electrical systems for buildings, equipment, and other applications. It involves determining the electrical loads, selecting appropriate wiring and components, and ensuring that the system meets all applicable safety and regulatory requirements. Electrical design is typically performed by electrical engineers or licensed electricians. They use specialized software and tools to create detailed drawings and specifications for the electrical system. The electrical design process typically includes the following steps. Firstly, determining the electrical loads. This involves calculating the amount of power that will be required by all of the electrical equipment and appliances in the building or system. Secondly, selecting the appropriate wiring and components. This involves choosing the correct size and type of wiring, circuit breakers, transformers, and other components to safely and reliably handle the electrical loads. Thirdly, creating electrical drawings and specifications. This involves producing detailed drawings and specifications that show the layout of the electrical system, the location of all components, and the wiring connections. Fourthly, ensuring compliance with safety and regulatory requirements. This involves making sure that the electrical system meets all applicable building codes, electrical codes, and other regulations. Electrical design is a critical aspect of building construction and renovation. A well-designed electrical system is essential for ensuring the safety, reliability, and efficiency of the building. Professional engineer licensure is a process by which engineers are licensed to practice engineering in a particular state or jurisdiction. The requirements for licensure vary by state, but they typically include the following. Firstly, graduation from an accredited engineering program. Secondly, passage of the Fundamentals of Engineering exam. Thirdly, completion of a specified amount of engineering experience under the supervision of a licensed engineer. Fourthly, passage of the Principles and Practice of Engineering exam. Once an engineer has met all of the requirements for licensure, they can apply to the State Licensing Board to obtain their P.E. license. A P.E. license allows an engineer to legally practice engineering in the state and to stamp engineering drawings and documents. Stamping engineering drawings and documents means that the licensed engineer is taking responsibility for the design and is certifying that it meets all applicable codes and standards. P.E. licensure is important for a number of reasons. Firstly, it protects the public by ensuring that only qualified engineers are allowed to practice engineering. Secondly, it provides a way for engineers to demonstrate their competence and expertise. Thirdly, it enhances the credibility and reputation of the engineering profession. Fourthly, it is often required for engineers to hold certain positions or to perform certain types of work. P.E. licensure is a valuable asset for engineers and for the public as a whole. It helps to ensure that engineering work is performed safely and competently and that the public is protected from harm. Continuing education is essential for professional engineers, often abbreviated P.E.S., to maintain their competency and stay abreast of the latest technological advancements, regulatory changes, and best practices in their respective fields. Most state licensing boards require P.E.S. to complete a certain number of professional development hours, often abbreviated PDH, on a regular basis, typically annually or biennially, as a condition of license renewal. The specific requirements for continuing education vary by state but generally include activities such as attending conferences, workshops, seminars, and training courses, completing online courses and webinars, participating in professional society meetings, teaching engineering courses, publishing technical papers or articles, and obtaining patents. The purpose of continuing education is to ensure that PEs maintain their knowledge and skills throughout their careers and that they are equipped to provide competent and ethical engineering services to the public. By engaging in continuing education activities, PEs can enhance their technical expertise, improve their problem-solving abilities, and stay informed about emerging trends and challenges in their fields. Continuing education also helps PEs to meet their ethical obligations to protect the public health, safety, and welfare. By staying up to date with the latest codes, standards, and regulations, PEs can ensure that their engineering designs and practices are safe, reliable, and compliant. In addition to meeting state licensing requirements, continuing education can also benefit PEs by enhancing their career prospects, increasing their earning potential, and improving their job satisfaction. By investing in their professional development, PEs can demonstrate their commitment to excellence and position themselves for leadership roles in their organizations and communities. The National Electrical Code, abbreviated NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, abbreviated NFPA, as NFPA 70. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address emerging safety concerns. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for the selection, installation, and maintenance of electrical equipment to ensure the safety of people and property. Compliance with the NEC is essential for preventing electrical shocks, fires, and other hazards. The NEC is enforced by state and local authorities who typically adopt it into their building codes. Electrical inspectors use the NEC as a guide to evaluate the safety of electrical installations. The NEC is not a design manual, but it provides a framework for electrical design and installation. Electrical engineers and contractors use the NEC to ensure that their designs and installations meet the minimum safety requirements. The NEC is a complex and comprehensive document, and it is important for electrical professionals to stay up to date with the latest edition. The NEC is available for purchase from the NFPA and other sources. It is also available online through various subscription services. The NEC is an essential resource for anyone involved in the design, installation, or inspection of electrical systems. It provides the information needed to ensure the safety of people and property.